Welcome to the Brookhaven Instruments Particle Solutions software training video. In this video, we will introduce you to the application and provide a tutorial for creating an SOP. When the software is launched, the main window is displayed. Familiarize yourself with the overall layout. The top menu bar contains a button for selecting the parameter that you would like to measure. The New button is for loading an existing SOP or for creating a new method. The window on the right shows the instrument connection status. Currently, it's showing instrument disconnected. The middle menu bar chooses which measurements you would like to review. So we can select again and pick the different measurements of which we have data already stored. Database allows us to import our legacy database or to save the current database as an archive file. Options allows for some configuration settings. And then there's also calculators for protein, polymer, and SPC. The row beneath provides for the ability to change the layout. We can select the basic mode, all columns, and then there are some other options. Selecting layout allows us to resize columns or add or remove columns. Selecting columns provides all the different options that we could choose to add, such as count rate or D10, D50, D90. Display allows us to show all measurements or selected measurements, including also a filter option to filter data that we'd like to review, specific date. Along the left side of the screen, we can choose measurements, which are the current DLS measurements that have been taken. We can graph those measurements. We can look at it as two variables, 3D graphs, reports that we can export as a PDF, and the health information of the measurements that were taken. Lastly, at the very top is a question mark. Selecting this will provide help information, including a quick start guide. So the next section of the video is like to be able to show you how to build your own SOP. We are going to select New in order to open up the new measurement window, which currently I'm not connected to an instrument, so I have to hit OK. And here's our new measurement window. If I click on SOP and I go down to Load, I can see the SOPs that are currently loaded within Particle Solution software for DLS. To create a new method, I'm going to select Default and click Open. From there, I am going to select Save As. And I will type in a file name for it, such as tutorial video. So any changes I make, I'm going to make them to the tutorial video SOP. We'll notice with the options for the SOP, there is a menu tree on the left, and then the fields to enter are on the right. It is important to note that there are these little helpful icons with the eye on there, and when we select those, there's contextual help to help you within the field that you're entering the information with. So there are 6 main categories to the SOP. There is identification, instrument, measurement, titration, sample parameters, and data analysis. Let's look at identification. The Identification tab allows for you to enter information to identify the sample when reviewing. The information includes a sample ID, the group ID, project ID, batch number, and a notes section to add any additional information about the samples being tested. If we select Instrument, there are 2 subcategories, Parameters and Correlator Layout. From there, we can choose the measurement angle, whether it's a forward scatter, 90-degree side scatter, or back scatter. Which options are going to be available are going to be dependent upon the instrument that you are using. Some instruments only have the side scatter, while others have the forward and back scatter as well. The correlator layout are pre-programmed settings, which include those for general use, nanoparticles, proteins, and advanced. If I select advanced, the correlator layout is now accessible. The wavelength will be automatically detected and is updated with the wavelength of the laser that's being used. Cell type, which includes for the type of cell that we are going to be using. The square cell plastic, or SCP, is our standard disposable plastic cuvette for use with saline and other water-based or aqueous samples. The square glass cell is for use with more aggressive organic solvents. The 50 microliter plastic cell is disposable, and sample cell adapter is required for its use. The 70 microliter plastic cell is also disposable and does not require a sample cell adapter. The 10 microliter quart cell is used for sizing small samples and for those that are very expensive. This cell type is reusable. Lastly, there's a round glass cell, which is used with solvents. This cell type requires a round cell adapter. It is important to note to be careful to choose the correct cell type for your sample. Using the wrong sample cell can severely damage your instrument due to chemical compatibility issues. For example, harsh solvents can melt or deform plastic. Also keep in mind that high temperature will also melt plastic. Extracting a melted plastic cuvette from a sample holder requires disassembly and potentially realignment of the instrument. Additionally, if you are analyzing samples above 70 degrees C, please use only the glass cuvettes regardless of the choice of solvent or diluent. Let's look at the correlator layout menu. Particle Solutions is currently the only benchtop light scattering instrumentation software that allows the user to customize correlator layout. We offer additional resources to help understanding the settings used and how to optimize them for a specific sample. We are not going to go through those settings at this time because it's very complex. Within the layout, there are options for channel spacing, the number of channels to be used, the delay range, the digital inputs circuits, and signal source. The first delay can be set from 0.5 microseconds all the way up to 40,000 microseconds. Selecting Verify Layout shows the allocation of channels along with the sampling time. Next in the tree is Measurement. The Measurement menu is the next option, and under the Parameters tab, the temperature, measurement duration, and equilibration time can be set. Please note that the measurement duration and equilibration time are in seconds. The default equilibration time is 300 seconds, which is the recommendation amount of time for samples to reach a specified temperature. If the sample is already pre-equilibrated to the target temperature, then it is possible to get a shorter equilibration time. For example, 60 seconds. Particle Solutions offers a powerful dust filter algorithm based on expected particle sizes to be measured. The dust filter can be toggled on and off even after a measurement is completed. The dust filter is an algorithm that rejects erroneous data such as dust contaminants or aggregates. You can either set the dust filter using a series of presets based on your expected particle size, or you can directly enter a dust cutoff value by selecting the custom value. In the Automation tab has the time-dependent and temperature-dependent submenus. The time-dependent menu allows you to choose how many measurements you would like to complete and the time interval between those measurements. It is possible to differentiate the replicates by not only start time, but also measurement number, which can be annotated to the sample ID by selecting the checkbox. The temperature-dependent submenu has settings for automation of temperature changes during a measurement. To enable the box, set the automation and uncheck when it's no longer needed. If measuring temperature is of interest to you, you may select a starting temperature and final temperature. You may also choose the increment between each new measurement. You can also add the temperature to the sample ID. The last field is automation completed temperature and is used to set the temperature for the start of the next analysis. Now if we look to titration, this is used if you have a Brookhaven Instruments BI-ZTU auto titrator. Please note that the ZTU is not a standalone instrument. It must be used with a nanobrook or other compatible light scattering product. The titration menu has three submenus, which are Setup, pH titration measurement, and Additive titration measurement. The Setup submenu allows for a selection of titrant, concentration, and units of measure. If we choose acid, our options are either nitric or unspecified. If we choose base, we have the option of potassium hydroxide, sodium hydroxide, or unspecified. Both allow for units of measure being in molar or millimolar. If we choose additive, there is a library of different types of additives we can use for descriptions, such as whether it's a surfactant, a dispersing agent, a wetting agent, and so forth. The units of measure range from percent weight volume, milligrams per mil, molar, and millimolar. Next is the pH titration measurement submenu, and this is used when performing studies to determine the influence of pH on a sample. To enable, check the Automate pH titration checkbox. Select the bottles with the titrants that you have. We are going to set our initial pH, our final pH, and the number of steps. The increment is a difference between the initial and final pH plus 1 divided by the number of steps. We are also going to input the sample volume that has been placed in the sample cup used with the BI-ZTU. Lastly, update the pH adjustment resolution. Brookhaven Instruments recommends a value of 0.2, however this can be changed as needed. The additive titration measurement submenu is used when performing studies to determine the influence of additive on a sample. To enable, check the Automate Additive Titration. Select all the bottles you wish to use. And we're going to set up our initial volume, the initial concentration of additive in the sample, the first concentration and last concentration, and the number of steps to be used between these two concentrations. Next in the menu tree is sample parameters. Within the sample parameters, there's for liquid and particles. The liquid submenu is pre-programmed with commonly used diluents. So we can see inside here we have water, ethanol, methanol, toluene, and so forth. Selecting one of the pre-programmed diluents will automatically up the viscosity and refractive index values. If you are using an unspecified diluent, you will need to add in the viscosity and refractive index, since these values are necessary in order to perform the calculations. The warning sign will show for a a diluent that is going to be a solvent that's going to be making sure that you use the correct sample cell. So since we have a plastic cuvette and using with hexane, it's showing us that there's a warning and we need to be doing something different with our sample cell. The pH field is for record-keeping purposes only. You do not need to input a pH value. This does not affect the calculated size of your particles. The particle submenu allows for the user to enter the refractive index of their particles in a field titled real. This number only affects volume, surface area, and number-weighted distributions. You may enter 0 in the imaginary field unless you're measuring color particles that absorb light. You can select whether your particles are uniform spheres or thin shells. And lastly, you may enter a concentration. This is for record-keeping purposes only and will not affect your particle size. This field is useful for plotting size versus concentration. The last main category in our menu tree here is for data analysis. In this menu, there are submenus for normalization, size distribution, and molecular weight analysis. In the normalization submenu, there are options for baseline normalization. Selecting an option is necessary in order to calculate particle size. These options include auto slope analysis, last channels, and calculated. Auto slope analysis is a default method and is used for most samples. In some cases, you may wish to choose fewer channels to calculate it. Refer to the manual for a comparison of these methods. In the size distribution submenu are options for size distribution. We can choose NNLS for fixed narrow decays and multimodal distributions, or we can choose contin for broad distributions. The range selection allows the range of particles in a distribution to be automatically calculated or can be set to a fixed range by diameter. The threshold setting is used to ignore small peaks arising from noisy correlation functions when transforming from intensity to volume weighting. The last submenu is the molecular weight analysis. In this submenu are a variety of polymers that when one is selected, the polymer type and solvent are updated, and the values used in the Mark-Huink-Sakurada equation for determining molecular weight. When we click the Save button, we are prompted, do we want to replace our existing files? Since I made some changes, yes, I'd like to save it as a new method. We'll save it as this method. The instrument is now ready to perform a measurement. If a sample was present, we would hit the Start key and analysis would be performed. Thank you for watching the Particle Solutions introduction video. If you have any questions, then please reach out to us by using the contact form on our website at www.brookhaveninstruments.com or by sending an email to info@brookhaveninstruments.com.